Let's begin with the topic what we have studied in our previous classes. And after that, we will start with the topic of today's topic, what we are going to study. Okay, so let's start. In the previous topics, what we have studied, we have completed our Bohr's atomic principle, and we have checked out the Heisenberg uncertainty principle as well as photoelectric effect. Okay, rather than I have given you a brief idea that we have so many orbits that are around a nucleus, which is moving, and each orbit behaves like a fixed circular path on which an electron is moving. Okay, so I have given you a brief idea that there must be some shape, size, and orientation on the basis of which we can differentiate these orbitals, and we can have some values, we can say some numerical concept of these orbitals. Okay, so let's start with today's topic. In today's topic, I'm going to take you with a particular topic that is known as quantum numbers. What are the quantum numbers and why do we need to study quantum numbers? Let's start. See, we know very well that the orbits that are moving around the nucleus that are based on the size as well as shape and the orientation. If I'm talking about the size, it would be very easy for us. It would be very important for us to calculate, to find out where the electron is actually present. If we have come to know about the concept of the size of the orbits, it would be very easy for us that yes, this is our orbit, and these are electrons which are revolving around it. Okay, so this is the first point. Second, I'm talking about the shape as well as the orientation. On the basis of shape and orientation, we can easily differentiate that yes, these orbits must have the electrons in these particular directions. Or we can say the probability of finding electron in this direction would be much greater, would be much easier. Okay, so these were the concept on the basis of which we need to have a new topic, that is quantum numbers. So quantum numbers is basically a mathematical concept, a mathematical derivation of finding out the maximum information about the orbitals. I'm repeating it again. Quantum number is nothing else. It's just a mathematical concept which gives us maximum information about the orbits that are revolving around the nucleus. So that are fixed around the nucleus. Okay. So let's begin with the topics, what quantum numbers want to explain to us. See, talking about, I was given a brief idea about the quantum numbers. Okay. So now ever, what I have told you that we have basically 4 types of quantum numbers which give us the actual idea about the particular topic, about the shape, size, and orientation of orbits. So first one, we have the principal quantum number, that is n. The principal quantum number basically gives us the size of orbitals. And this is also known as principal quantum number. It is the basic quantum number on the basis of which we can differentiate that yes, this is our first orbital, this is our second orbital, this is third, and so on. Okay, so let's start. Suppose we are having n equals to 1, 2, 3, and so on. So n could be any positive integer, it could be 1, 2, 3, and so on. And this 1, 2, 3 basically represent us about the shell. K, L, M, N, P, and so on. I hope you have heard about these shells, that if I'm nucleus and these are the orbits that are around us, suppose this is n equals to 1, this is n equals to 2, this is n equals to 3. This n is representing us the principal quantum number, and it gives us the values. Suppose this is K, this is L, this is M, this is N, and so on. Okay, these K, L, M, N are represented the shell. You have must heard that the electrons are revolving in a shell, and they can easily jump from one level to another level. So these are basically shells in which our electrons are filled. Have you heard that electrons are 2, 8, 8, 18? That in the first cell only 2 electrons can be filled, in the second 8 shell, 18 shell. So these are the shells which are represented by principal quantum number. And this is the actual concept behind this principal quantum number. Okay, so let me recapitulate what I have told you. The n is the basic principal quantum number, the first principal quantum number. That's why we have given it the name principal quantum number or principal orbital quantum number. And it gives us the exact idea about the size of orbital. That's why we have also given the name that it gives us the value about the shells, that how many shells are actually present around the nucleus. And these are represented by 1, 2, 3, 4, and so on, where 1 is representing our K shell, L shell, M, N, and so on. These K, L, M, N shell, these are just a way to represent the shell in the form of alphabetical order, nothing else. This is nothing much physical importance. It just gives us the idea that we can describe it also in the form of mathematical as well as our alphabetical ones. Okay, so now let's begin with our next topic, that is second quantum number, which is known as azimuthal quantum number. Let's start. The second one is our azimuthal orbital quantum number, which is denoted by L, small l. Okay, now let's start what small l wants to say to us. Basically, this particular quantum number, in the previous one, we have studied that the n has told us about the size. But if I'm talking about L, this actually gives us three-dimensional shape of the orbit. Three-dimensional shape of the orbit. Okay. And most importantly, the L must be equal to n minus 1. So if I'm talking about n equals to 1, then L must be equal to 0. If I'm talking about n equals to 2, then L must be equals to 1, and so on. Okay, this is known as our subsidiary quantum number or azimuthal orbital quantum number. Okay, now why do we have to need of this L? I have already told you that in our n quantum number, in our principal quantum number, we have described the shells. But if I'm talking about another one, it is basically giving us the idea of subshell. Okay, so L is giving us the value of subshells. And most importantly, which is the most important topic that I'm going to share with you, that if I'm having value 0, 1, 2, 3, 4, then we are representing it as S, P, D, F, G, and so on. I hope you have heard about 1S, 2S, 3S, 3P, 4S. So these S, P, D, F, and G, these are represented by subshells. और हमें ये बात 110% remember रखनी है that 0 represent our S, 1 represent our P, 2 represent our D, 3 F, and so on. So these SPDF are basically our subshell on the basis of which we can put our electron, we can actually calculate how our orbitals are represented. Okay, so this is our subsidiary orbital quantum number or azimuthal quantum number. I hope this was the topic you have cleared that. Now, next we're going to move with the third quantum number that is known as magnetic orbital quantum number. The third one is known as magnetic orbital quantum number. Now, what magnetic orbital quantum number wants to describe to us? Let's see, let's have a brief discussion. In our first two orbitals, in our first two quantum numbers, whatever I was talking about, the principal quantum number or my azimuthal quantum number, they have given us the shape and the size. Now, the magnetic orbital quantum number, which is also represented by ML, it is totally dependent on our quantum number L. यानी अगर हमें L की वैल्यू पता है, then we can easily go on with the value of ML. It's totally dependent on the L value. Okay. And what magnetic orbital quantum number describes us? It is basically giving us the spatial orientation. The spatial orientation means the orientation of orbital in space. So basically ये भी हमें 3 dimension में direction के बारे में बता रहा है rather than the size or shape. Or most importantly, it's quite dependent on our orbital quantum number, that is L. Okay, so magnetic orbital quantum number ने हमें क्या क्या बताया? It gives us the spatial orientation. That means it gives us direction in 3 dimensions rather than the shape and size. This was the first point. Second point, if we know about L, we can easily move on with our ML quantum number. Okay, let's see how ML is dependent upon L. Let's take an example. If I'm talking about, let's say, L equals to 0, then ML must be equals to 0, but ML equals to minus L minus 1, so on 0 up to plus L. So in short, I can say ML equals to minus L, 0 and plus L. जितनी भी value, how many value come between minus L to plus L, we would take them in a positive integer form. Let's take an example. Let me rub this first one. Let's have an example with what I have given you. ML, it gives us value minus L, 0, plus L. Let's I'm talking about that ML equals to 1. Sorry, L equals to 1. Then ML must be equals to minus 1, 0 and plus 1. If I'm talking about L equals to 2, ML must be equals to minus 2, minus 1, 0, plus 1 and plus 2 and so on. Same as it is if it is 3, it would be equals to minus 3, minus 2, minus 1, 0, 1, 2 and 3. Okay, so this is how our ML is totally dependent on our L quantum number. Now the point here arises कि इसका कुछ benefit भी है या we are just going to study it with the help of ML should be this, ML should be that. So what we have any kind of physical importance with this topic? Definitely yes. We have heard about the orbitals. So let's talk. Let's have a look about S orbital, P, D, and F. और हमने अभी study किया है that if L equals to 0, it is S. If L equals to 1, it is P, and so on. Okay. So it has given us the value if L equals to 0, ML must be equals to 0. That means there is only one possibility. So for S, there is one kind of orbital. If I'm talking about L equals to 1, that means minus 1, 0, plus 1. That means we have 3 possibilities. So if I'm talking about P, there must be 3 different orbitals in which our electron can be filled. This is super important and super easy topic. If I'm talking about my ML, my L value and ML values can be represented with the basis of this. Suppose we have 3 values, we have 4 values and so on. On the basis of this, we can easily explain that yes, P has three orbitals, p has three subshell in which electrons can be filled, in which electrons can be arranged. Now, if I'm talking about D, how many possibility? 1, 2, 3, 4, and 5. So D must have 1, 2, 3, 4, and 5 possibilities in which electrons can be. Okay, this is the brief discussion about ML quantum number. Same as it is for the F, there are 7 possibilities. So there must be 7 orbitals. Okay, now the point here arises, why do we need to study them? Sorry, we have studied them, but on the basis of this, we can have another discussion, we can have another conclusion that there must be these many number of electrons. Just double them, just square them. How? If I'm talking about S, there can be only 2 electrons filled. This is representation of an electron. This half arrow, ये हमें एक इलेक्ट्रॉन को रिप्रेजेंट करता है, and we will see कि हमने इनको अपोजिट डायरेक्शन में क्यों रखा है. In our higher topic, whenever we will move with some laws, we will see why we have put them in opposite direction. Okay, so same as it is if I'm talking about P, कितने इलेक्ट्रॉन्स हमारे फिल हो सकते हैं? टोटल 6. So if we have 3 type of orbitals, there should be 2 ml orientations. There should be the possibility of twice of that ml in which we can place our electrons. Okay, this was all about n, l, and ml. These were 3 possible quantum numbers which give us about the shape, size, and lastly it told about the direction, about the orientation. Okay, now what happened when we have discussed these all 3? We are left with only one quantum number which gives us only about the direction of electron. It doesn't give any other information about orbitals. It just gives us the value, the direction, that how we can place our electron. That means we have seen that the electrons can be in 2 directions, either in the upper side or in the lower side. This is represented by our 4th quantum number known as spin quantum number, or we can say electron spin quantum number. Okay. So lastly, we're moving. What we are going to study, electron spin quantum number, which is represented by ms. It just gives us the value about the spin orientation. See, you know very well, if I'm talking about the circular path, we have only 2 directions. One is clockwise and second one is anti-clockwise. In the very same way, our electrons are also represented in the form of spin, either in the clockwise or in the anti-clockwise. So if I'm representing this, that means this is plus 1/2 clockwise direction. यानी मैं ये बोल सकती हूँ कि in our orbital, electron is moving in the clockwise direction. Okay, same as it is if I'm representing this, this would be minus 1/2, that is anti-clockwise. Yani I can say that my electron is revolving in anti-clockwise direction. Okay, these were only 2 possibilities how the spinning of an electron can be possible. So on the basis of this, we have given the last quantum which is represented by ms, which have only 2 value, either plus 1/2 or minus 1/2. So it is totally independent to the all 3 quantum numbers, not on n, l, and m. Okay, so this was all about the quantum numbers. Let me recapitulate. We have studied about m, l, and there was ml, and finally ms. The first n represented the principal quantum number, which gave us 1, 2, 3 value, k, l, m, n. Second, we have l, which represented orbital quantum number, sorry, azimuthal quantum number or subsidiary quantum number, and which is represented as 0, 1, 2, 3, small s, small p, small d, small f, g, and so on. Finally, we had ml, on the basis of which we have calculated how many number of orbitals are possible. On the basis of minus L, 0, plus L. And finally, what we have? MS, which just gave us about the spin orientation. Either it could be -1/2 or +1. So this was all about quantum numbers, which is very important, and we will see them that how can we use them in calculating our numerical formulas. Abhi tak, I have just given you a brief discussion. I have given you about the introduction as well as the theoretical concept. Now we will see how these are practically possible to us. How can we use them to make our numericals easy, to represent our orbitals? Okay, so let's start with 2-3 examples. First one, let's start with the question with problem 2.18 that's given in your in-text question. Let's start. The question has given us the 4 quantum numbers, and we have to represent that which orbital it is representing. Okay, so let's see how is it possible. It has given n equals to 2 and L equals to 1, and you have to tell that which orbital this would be represented. So class, this is super important. You must tell me how is it even possible. N equals to 2, L equals to 1. So 2 is the principal quantum number which is representing the actual shell. It could be K or L, so it is L. And L equals to 1, 0, 1, 2, 3. That means SP, DF. So it would be 2. So simple it is. And L equals to 1, the orbital would be 2. Okay. Now let's have another question. N equals to 4, L equals to 0. L equals to 0 represent S. So it would be 4S. Same as it is. N equals to 3, L equals to 2. It would be 3D. Okay. Now I'm going to take some more questions in which you will see which orbital set is possible and which one is not possible. Okay, so let's start with your questions. Yes, we are having let's say n equals to 1, L equals to 0, ml equals to -1/2. Is it? Yes, definitely it is possible. This is 1s and ml must be equals to -L, 0 plus L. Since we are having L equals to 0, so ml must be only have one value which we have studied. ms equals to -1/2. This is true. So this is possible. But what if we having n equals to 1 and L equals to 1 and same value ml equals to 0, ms equals to -1? Is it possible? No, this is not possible, because I have told you that L must be less than N. L must be equals to N minus 1. So if we are having L equals to 0, then it is possible. If L equals to 1, this is not even possible. So this orbital we cannot form. Okay. Now on the basis of another example, let's see. Suppose I'm having 3p, and you need to describe all the 4 quantum numbers on the basis of this. So super simple. N equals to 3, L equals to what? 1, ml equals to -0 plus 1, and ms could be either -1/2 or +1/2. Okay, so this is the way how we can take help of our quantum numbers. This is the way how we can represent that, yes, these are the quantum numbers. Okay, class? So this was the total concept. If you have any doubt or query, we will see. But before that, I will going to show you a little bit new topic, that is, what is the difference between orbit and orbital. See, अभी तक जो मैं डील कर रही थी in our previous classes, I was talking about only the orbits. और अभी मैं जो बात कर रही हूँ, मैं बात कर रही हूँ about orbitals and orbit. So there should be a query in your mind, ma'am, what is the difference between the orbit and orbital? Somewhere you're talking about orbit, somewhere you're talking about orbital. Isn't it confusing? So what is the difference between orbit and orbital, and what are its significance to us? We will see. That is a theoretical topic. Basically, orbit and orbital, these two are quite different. These two are totally different to each other. And if I'm talking about only the orbit, it is nothing, it's just a theoretical concept which give us that these are the circular path that revolve around the nucleus. So these are the orbits. This is new. It has no physical significance. It's just a theoretical concept. We cannot determine it even experimentally. Okay, so orbit is not defined as it is a circular path that is around the nucleus in which electrons are revolving. That's it. But if I'm talking about orbital, this is somewhat which Bohr gave us in the form of mathematical. And we have this the help of psi. You have remembered in the last class I have given you the psi. What was psi? It was nothing. Psi was represented as it is a quantum mechanical mathematical formulation of, okay. So orbital could be defined as it is a quantum mechanical concept which refers to an that is known as psi. I would repeat it again. Orbital is nothing. It is a quantum mechanical concept which give us the value of an electron wave function. Okay, so this is the difference between orbit and orbital. In short, I'm saying orbital is giving us all the mathematical information, the maximum information we can gather from our orbital. Whereas orbit is nothing, it's just a circular path in which our electrons are moving. This is just a theoretical concept, whereas this is a mathematical concept. This is the biggest difference between orbit and orbit. Okay. Now we have completed all our concept about orbit, orbital, as well as the 4 quantum numbers. The 4 quantum numbers based on numericals on which these are super important. How can we represent our 1s, 2s, 3p, or on the basis of 2s, 3p, we need to represent our 4 different quantum numbers. These are super important numericals and very easy. We have seen that, but just we have to remember that what is M, what is L, what is ML, what is MS. Okay, so this was all about by my side in this particular class. If you have any kind of doubt or query, please ask me. Please feel free if you have any kind of doubt or query. Yes, students, if you have any doubt or query, please